Okay, let's look at the definition of a function. All right, a function f. So f is the name of the function from set A to set B is a correspondence that assigned to each element x in A. So it has to be every single element in set A. All right, so here's a punchline. Exactly one element, corresponding element y, which can be written as f of x in B. Right? So that's the rule. It's just a corresponding. For every single element in A, there must be exactly one element in B. Right? So let's look at the following diagrams. Right? Does this diagram represent a function? Right? So you can see that the 1 is mapped to A, 2 is mapped to C, and the 3 is also mapped to C. Right? For every single element in A, there is exactly one corresponding element. For example, here, 1 has A is the only corresponding element, right? 2, C is the only corresponding element. 3, C is the only corresponding element. So therefore, this is a perfectly good function. Right? So this is a function. Right? We can call this guy f. Right? And notation wise, we can write it this way also. Since 1 is mapped to A, we can write it as f of 1 is equal to A, right? And f of 2 is equal to C, right? Because 2 is mapped to C. And of course, f of 3 is equal to C, right? So this follows the definition, so it is a function, right? How about this second example, right? 1 is mapped to B, 2 is actually mapped to A and C, right? And this 3 is mapped to C, right? Does this diagram represent a function, right? The problem is troublemaker is 2. You can see that the 2 has a 2 separate corresponding element. So this guy actually violates the condition here, because every single element, especially 2, has to have exactly one corresponding element, but the 2 has actually 2 corresponding elements. So therefore, this guy is not a function. All right, so this is not a function. All right, and I would like to go over a couple of terminology. Set A is called the domain, so A is called the domain of function f. And set B has a name, so set B is, the textbook might not mention it, but I'll mention it anyway. It's called a codomain of f, right? And the range of the function, let's look at this example. The range of the function is all the elements in B that has arrows coming in. So for example, here A has an arrow coming in and B doesn't, and C has 2 arrows coming in. So the set with only A and C in this example, right, this set is called the range. So this guy is the range of f, right? So in this case, the range of f, you can also write it in curly brackets. So you have a set with a and a c in it, right? So this is the range of f, right? That's it. I hope that this was clear.